Greetings. What we've got here is a rather large UPS. It's an APC Silcon DP320 and it's not a happy one. As you can see, it's starting to lose communication with itself. It's been sending countless emails out. Last night I received an email saying that it's actually turned itself off when it hadn't. So it's end of life. The batteries are 8 years old, so I'm going to put it into bypass, and at some point then we'll shut it down and take it to bits. So the first thing we need to do is actually get it to put itself in bypass. Then we can turn the switches over there to get it out of circuit. Right, now that's in bypass, it should be safe to turn these switches. You can see first of all I need to turn the middle switch on, which links the input straight to the output. Then I can turn the output off. And that's the UPS now officially out of service. You can see the power is now connecting straight to the input, straight to the output. The UPS can now be turned off. It's both buttons to turn it off. Unfortunately, you can hear the sound. It's still losing communication with itself. So the best bet now, we don't care about the batteries. The batteries are old, so I'll turn the power off to it. See, when it goes into alarm, you can't actually press any of these. It's only when it's there we go. You see, input voltage is off. Eventually, once the batteries run flat, it's going to shut itself off. The UPS has been off for 3 weeks and the battery's disconnected for a fortnight. So it's time to pop down the front panel and unload the batteries. There are 64 batteries in 8 slabs of 8, one of which blew about 5 minutes after the UPS was powered down. And it's this one. Here's a quick view around the system before I take it apart. As you can see, there's a lot of electronics in this thing. Here's the system gutted, and all the boards out. Let's take a look at the boards one by one. Now, the Silcon is a delta conversion UPS, and that involves two converters, both of which can convert DC to AC or AC to DC. They're both bidirectional. And you've got your main inverter, which can take the battery supply and power the load from it. And you also have the delta inverter, which regulates the supply, which goes through to the load side of the main inverter. And it can do this by sort of basically adding or subtracting power from the input, hence the delta is the change. And this is the heart of that, it's the delta transformer. It's 3 single-phase transformers, each with a 1:5 turns ratio. So the main power will go straight through on these connections here. So the power will flow straight through, and if the delta converter is doing nothing, it would just go straight through as it is. But it's a 1:5 turns ratio with this supply, with this connection it's as well, and again there's one on each. And these you can put, for example, if you put a 300 volt supply on this, depending on the polarity in relation to the input supply, you could add or subtract 60 volts from the 400 volts phase-to-phase supply. So you can go from 340 volts up to 460, and you'd still get a nominal 400 volts on the bus from the load side of this delta transformer, and this one of course, through to the load side of the main inverter. The main inverter wouldn't actually be doing anything, or it may actually be supplying power back to the delta converter and onwards to the load. So that's where the delta converter comes in. If you want to see more about this, if you look on the APC website and look in their documentation page and do a search for delta conversion, there's a whole bunch of data sheets and white papers and things which will just fry your head on the way these things work. So that's the delta transformer, the big heavy thing out the way. What else do we have? Well, the supply flows through these two almost identical boards. And you can see that they're the same. It's the same circuit layout. It's just one is more populated than the other. And you're able to see these boards on the left-hand wall, just behind the input and output terminals, and above and to the left of the delta transformer. It appears mainly to be a few inductors. There's these inductors here which are linked out on this model. This seems to be identical on both, and a few capacitors. This one has additional connectivity, additional fused connectivity off on these connections here. Staying on the power side for now, we have this module, and the entire module, it's interesting because even though it was mounted on slide rails, the whole thing is isolated from the chassis. It's actually a live case. I don't know whether it's battery voltage, or presumably it's a battery live voltage rather than a random one of the 3 phases. But it's, as I said, it's live, so it's got this plastic insulation and it's spaced off. I'll take this apart and we'll see what makes up this one unit. Now, I don't know whether this is the main inverter or whether it's the delta one. I suppose we'll find out as we dismantle the rest of the system. Now, what we've got here, apart from a lot of fuses, is a bunch of these caps. There's really big caps everywhere on this thing. These are 10 microfarad 600 volt DC caps, and this connects down to a set of 3 Toshiba IGBTs, which are MG75Q 2IS50. And we'll have a
look at that later on. So that's this board. Again, like I said, there's caps everywhere. Caps and big resistors seems to be the order of the day on the brawn of this outfit. And the fact that these are on quite a chunky heatsink and connected to some ridiculously big capacitors tells me it may in fact be the main inverter. And by beefy capacitors I don't mean the ones on the board. If you take a look at this, I think this is out of a flash gun, and it's 400 volts, 4.7 microfarad. This will give you a nasty nip. And if this will give you a nasty nip, what do you think these will do? These are 2200 microfarad, 500 volts, and there are 4 of them. So there's some serious juice on that, which tells me, oh, by the way, this is the heatsink on the back of those IGBTs. I think this is the main inverter. This is the board driving the IGBTs, and there are a lot of these very almost symmetrical, I think, circuits. There's 6, so presumably 2 for each of the IGBTs, and they've got these, if I just zoom in on one of them, you've got these twin optocouplers here. I think this transformer is just to provide power for this part of the board from this part of the board. So even though it's isolated here, and then this provides an isolated supply across. You can see there's a pair of diodes here as well, so probably part of the circuit. There's a MOSFET, there's a comparator, and they're all pretty much identical setups, I think, for all 6 of them. And elsewhere there's some 74HC series logic, and there are a few other components as well. What did I spot? There's a TL084 there, which is an op amp, and a MOSFET driver there, a TC4427 CPA. I don't know these off by heart, as if you see my hand disappear, I'm actually going to check online to see what these chips are. So that's the IGBT driver board, and underneath here then there's another board. I'll put this down to one side, and this one was actually soldered through. It took quite a bit of desoldering to get this off. You can see again there's a 3 circuits again with one of these transformers. So I think those circuits are very similar once again to the ones on the other board, and these this time connect down to this, and of course you can see another 3 matching ones. So I think it's the same thing again, just a different orientation, and these connect to, apart from that, this, which is, and that's an MG, it's a Toshiba MG15 Q6 ES42, and that's another IGBT. Now this is out the way, we can see the capacitors in all their glory, and once again there's that flash gun cap to compare. Those are serious caps, and that's also a serious piece of semiconductor as well. That's a Westcode CMK 450 B19M. Oh, sorry, I think that's not the actual part. I think that is the part number of the this actual mounting assembly. I'm not sure what's inside it. I'll have to take a look. I've taken the bolts out. Let's see what it is. And it's quite a weighty little capsule. So we can find that part number. Rest it up so I can see what's on it. Well, as far as I can see, that's a 1600 volt 600 amp thyristor. So quite a chunky little beast. And we might as well take a quick look at the mounting unit for that as well. There's a copper base plate with connection for a stud as well. Then you have your capsule, which will go some way around on there, and we have this, and I can pop this apart. You can see we've got this. Presumably these spacers will allow for adjustment of the whole thing to suit different thickness capsules. You can see that pops in there, then you got those, and that then goes on. This goes down like that. This goes on as well, and you can then spin these down. These aren't these don't adjust the height of the, these aren't for locking the thing in place, they're just for locking the cables in place. So there's 3 of these, 2 which will go below and 1 which will go above the connector. And this just bolts together. Obviously once you've got the spacers in, you put these in as well, and all you have to do is tighten these all the way up as far as they go, and it's clamped down to the correct pressure. This board, I think, is a charging board. There's an option in the menu for when you're starting the system up, so you can actually pre-charge the capacitors to avoid damage. In fact, I think it's an option which you've actually got to do as part of the startup. And what we've got here is a total of 54k of resistance. Each of these resistors is 7 watts. These are 27k a piece, as are these, and these are 18k a piece, and they're all series parallel connected. So these are parallel, 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 and all in series for a total of 54k, rated at 7 watts. Sorry, rated at 14 watts because they doubled up. Before I go on to the next big power board, just a quick look at these things, which are 3 massive Dantrafo DT13801-3, which look like they're chokes. The tester thinks they're 0.3 ohm, 0.61 millihenries. They're certainly big, and there's 3 of them, so presumably again 1 per phase. This is another section from the power side. This was sitting in the unit to the rear of the module you just saw, and we have 2 great big contactors here, which I think are the 50 amp contactors. One of which I think is probably for well, they're both bypass contactors really, if it needs to bypass the system and pass power straight through. I think there's one, I think looking at this, some of the stuff online, one is a backfeed protector, so if the if it all of a sudden the UPS is providing power, all it's doing is providing power out, it can cut the power and make sure it's not back feeding. And the other one will be a maintenance bypass then, which will completely sort of put the, pass all the input straight through to the output, so that the UPS can be put into maintenance. I think that's what these will be anyway. So that's on the one side. On the other side we have some more boards. The other board I forgot to mention on the back was this, which is just 3 current transformers with a few resistors in parallel with them as well, presumably to prevent if you try to run a load through them without anything across them, they tend to go crazy voltage, I believe. So there's that. This board, it's got a lot of connections down to what look like SCRs. There might be IGBTs, I'll take a look later on down here. But all these, from what I can see, are LM317T voltage regulators, and they seem to take their own independent voltage taps from these two transformers. These transformers have what appears to be a primary winding here with lots of independent secondary windings. So it looks like it's basically a big power supply board. But there are also a few opto-isolators as well, and some glue logic and transistor arrays and whatnot on there as well. So a little bit of brains and a lot of brawn in what appears to be a big multi-output power supply. Underneath that was this basic power board with these connectors, and as I thought, these SCRs, in fact they're dual SCRs. These are each rated 95 amps at 1200 volts. This is the last of the big power ones, and this actually sat along the top with a big piece of plastic over the top with big warnings saying don't touch anything, these fuses are live, even when you chip the breakers off they're still live. It came with this little plastic, purple plastic fuse puller, it looked like a plastic pair of pliers. I don't know where it's got to now, but this dealt with the battery input. I think the batteries came in on this connection here from down below, and I don't think there was anything connected on the others. And then there was the connection there which went off. I think that went off, that might have gone off to the big capacitor bank, and I can't remember. I'd have to look back for that. But basically this deals with all the high voltage DC bus. There's two 384 volt strings of batteries as basically one long string really, but it connected up to here in two halves, and those are actually isolatable. Once you told the system, once you shut the system down, you could actually flip these out and remove these fuses to completely isolate the battery bus. This probably counts more as the brawn rather than the brains, and it's the fan. Here's the control board, and here's the fan itself, which ventilates between the power side and the battery side of the compartment. At last we get to the brains of the outfit. In fact, 4 brains of the outfit. This is the main control board, and we have an 80C196 20 MHz 16-bit microcontroller and 3 SAB 80C535N 8-bit microcontrollers, which are 12 MHz ones. There's an 82C55A programmable peripheral interface and an SCN 2681 AC1M40, which is a dual UART for serial connections. We have 2 27C256s with the same code on them, so presumably these run as a pair, they do the same job. There's another 27C256 with a different code. This is a 27C512, presumably for the 80C196. There's 64 kilobits of EEPROM, and 64 kilobits of real-time clock, and a few PAL 20 V8s. There's one there, and one there, and the rest is all glue logic. And the connections from here then go off to the various boards, front panel boards, the power units themselves. This will go to a power board, and this one goes to a parallel board, which we'll come to shortly. And in fact, we'll come to it next. This is the parallel UPS board. There's a load of opto-isolators and some glue logic and 1 or 2 op amps on there as well. And this board is responsible for linking several UPS systems together. The UPS which I've dismantled was originally part of a parallel pair. Between the two of them they had, it was over a 20 kilowatt load. So they weren't running in redundant mode, they were just running purely parallel to sort of load share between them. You can have several UPSs together and have them linked with these connections here. And for example, an N+1 redundancy thing where you've got, say, 5 UPSs, the load would be handled by any 4 of them, and you can take one of them down for maintenance without losing any resilience. In case of power failure, the rest can handle the load, then you can bring that one back in, take the next one at service and whatnot, and so on. If you're not running as a redundant set, this board is disconnected or maybe not even there at all. Both those boards get run off this power supply. It looks to me like 2 power supplies in one. It may not be, because of the connections underneath. A lot of the connections from the one transformer go straight into the board. The other one seems to be a lot more sparsely connected, as you can see. But something I did notice on this, wonderful bit of quality control from APC here. This capacitor here was never connected. The pin doesn't go through. It managed to work for over 13 years like that, so obviously can't be that important. This board is from the lower front panel just in front of the batteries, and will connect back using these optical connections with a pair of fibre optic cables back to the main control board. They just fit into the front and screw tighten up. Again, it's got an APC 196 KC20 microcontroller, so it's another 16-bit 20 MHz microcontroller. There's 64K of static RAM, 64 kilobits of static RAM, 2 27C512 EEPROMs, and another pair of dual UARTs. This board will also connect off to an external card. If you're running a network management card, it'll plug into one of these ports of the cable, and also connects up to the front panel. Presumably this is where the issue was, where it was losing communication between the front panel and the main board. Presumably the fault was either here, or I doubt if it's in the fibre optic connection. And just above this board we have this board. This board connects off to the status indicators and contacts on the bypass panel, the rotary switch bypass panel. On a Silcon bypass panel, it's got indicator LEDs which indicate when you turn the bypass, when you put it into bypass, you'll get an indicator light indicating by the bypass panel, by the bypass switch, that it's now okay to turn that. When you turn that, you get indicators on the other light switches to say it's now safe to turn these. On the panel you saw here, it's actually for a SmartOps VT, which has got the same switches and the same connection contacts, but doesn't have the LEDs. See, it's also got options for selecting between internal and external battery cabinet monitoring, and you can also choose, you've got these emergency shutdown connections as well. That just leaves the front panel to look at. In here we have an APC 51 microcontroller, which is the same family as the 3 on the main board. There's a 27C512 EEPROM, which is surprisingly big, I think, for what this is doing. I mean, it's only controlling the front panel. There's a little bit of glue logic on the board and one hidden away underneath. There's a MAX 707, which is a micropower supervisory control chip. There's an X9511ZP, which is a push-button potentiometer. And that's it. You see, there is provision here for additional chips, because it is possible to have an external version of this with external power and obviously a 9-pin DIN connector, so it can be mounted away from the UPS. And that's it. That's everything you will find inside a Silcon DP320 20 kilowatts delta conversion UPS. Hope someone finds this useful or interesting or whatever. Thanks for watching.